Well, thank you for being here. Thank you for having me. So yes, the talk is sort of the trailer for the book that I'm going to publish next year. Usually authors, first of all, they write a book and then they do a talk about it. I decided to do the opposite, to first put together a talk and then write a book about the talk. So basically the book that I will publish next year will be an expansion of what you are going to see today. Obviously, it will contain many more examples. The title of the book, by the way, is not going to be Visual Trumpery. I would like to address the title of the talk a little bit, because it's a title that is intended to mislead people. The actual title of the talk is the subtitle that you see over there, How Charts Lie and How Can Charts Make Us Smarter Instead, right? But when I was putting the talk together, the slides of the talk together, you know, in conversation with some friends and people who I know and who are very good at communicating, they say, you know, if you include the word charts or the word data in the title of the talk, you will scare away a lot of people. So you need to come up with a better title that may attract bigger audiences. And fortunately, right after the 2016 presidential election, a friend of mine who I follow in social media tweeted the meaning of the English word trumpery, which is a very, very old word in the English language. I have the meaning of the word over there. That's the tweet that my friend sent. Because trumpery is something that deceives the eye. A trumpery is something that lies. In particular, something that lies your perception, your visual perception. So I say, this is perfect. It's perfect title for the talk. First of all, because it will help me attract bigger audiences, all right? Second, because it's such a catchy title, right? Considering the current political and cultural situation here in the US. Welcome, come on in. Also, second of all, because it will also, it's also related to the content of the talk, because I'm going to talk about trumperies today, right? Graphics that deceive you, all right? Graphics that deceive us, all of us. And third of all, because it also helps me make the first point during the talk, which is that in order to understand any sort of message, like news stories, a chart, and so on and so forth, we should always read beyond the title of the story if we want to understand it correctly, right? So in order to understand what this talk is about, we need to go way beyond the title of the talk. A little bit more housekeeping. This talk is open source. So I am going to share the slides freely with you. The slides can be found in that a Google link that you have over there that will take you to a Dropbox folder in which I have put all the different versions of this talk in the last couple of years, so you can take a look at it. And also I have included several extra readings that expand on the contents of the talk itself. As I said, the talk is completely open source, so if you want to use or repurpose these slides and spread the word about the ideas that I'm about to present in your classes or with friends, with your family, etc., feel free to use these slides with no permission from me. If you didn't have time to take a picture of the screen to get the link, you can always email me, and I will be happy to send you the link to this Dropbox folder. Anyway, so let's get started. This talk is both a celebration and a concern, and it's a way for me to share a concern that I have about the things that I do and the things that I teach. I would like to begin with the celebration part of the talk. It's going to be the shortest part of the talk, but it's a very important one. I do believe that charts are worth celebrating. I think that we are living through a golden age of charting or data visualization. That's the fancy word. Or the term that we can use also to refer to charts. For me, a chart is any sort of visual representation of information in order to inform a public, or inform the general public. And my entire career has been devoted to either designing charts of different kinds. These are screenshots of several infographics, data visualizations, visual explanations that I have done throughout the years in news publications in Spain, the United States, Brazil, and so on and so forth. I began my career doing pictorial visualizations, visual explanations of stories, right? How a machine works, or how the latest spaceship from NASA works, and things like that. And later on, I began doing more data visualizations, visual representations of data through maps and graphs and charts of different kinds. Anyway, so I'm going to focus today a little bit more on the data visualization part, right? Any data visualization is basically consists of the transformation of numbers into objects, right? The whole idea behind charts, right, visual representations of data, is that we begin with a bunch of numbers, and then what we do is to map those numbers onto objects. And then we vary certain properties of those objects according to the numbers that we are trying to represent. That sounds like a mouthful, but it's very easy to understand. You may begin with 5 numbers. You select, for example, a rectangle, and then what you do is to change the length or the height of that rectangle, of those rectangles, according to the numbers that you're trying to represent in proportion to those numbers, right? But there are many other ways of representing information, representing data in data visualization, in charts, right? There are different methods of encoding, we call them that way, or aesthetics, right? Methods of encoding in general consist of changing those, right? It could be, for example, the area of an object, like in the case of a bubble chart. It could be the thickness of a line. It could be the color of an object or the shade of color of a particular object, right? That's usually the method of encoding that is used in maps when we represent, for example, the results of election. And as I said before, I do believe that we are going through a golden age of charts, a golden age of data visualization. And data visualization is becoming, or has the potential to become, a mainstream language. I am a great believer in that data visualization, the use of charts to communicate, can eventually become like written or spoken language, something that anybody and everybody can use to either understand data better or to communicate messages to other people. I'm really excited about that possibility. The reason why a visualization is useful, right, is that if you see that, right, you will not be able to figure out what's going on, right? So this is a large spreadsheet that contains data from all over the world. Is average global temperatures in the world from the year 1000 up to the year 2000 in Celsius degrees, all right, which I really like. I'm European, I use Celsius. In comparison to the average temperature, global temperatures between the year 1961 and 1990. That's the reason why you see negative values and positive values. That means the temperature in this particular year was below that average, or the temperature in this particular year was above that average between 1961 and 1990. Now, visualization is a great way to answer questions out of the data. I'm going to ask you a question. Well, you already know the answer to this question, but imagine that you don't know the answer. The question that I have is, have global temperatures increased or decreased in the past 1,000 years? If you didn't know the answer to that question beforehand, right, answering that question just by taking a look at this data set will be impossible, because a normal human brain has a very hard time wrapping itself around large amounts of numbers. But when we get all those numbers and we map them onto an object, we transform those numbers into something that is almost physical, we start understanding and we start seeing the trends and patterns that hide, or that were hiding behind the data. This data set, by the way, is a very famous data set, is the origin of this chart. This chart is commonly called, if you want to Google it up later, the hockey stick chart, which is a chart that caused a lot of controversy after it was published. It was published originally in 2001, although it was designed between 1998 and 1999 by a group of environmental and climate scientists. And it tells you a very interesting story, and it reveals a very interesting pattern. The pattern that it reveals is that between the year 1000 up to the year 1900s, more or less, global temperatures more or less, they varied, right? They varied, but they varied within a certain range of temperatures, and usually below the average between 1961 and 1990, which is this black line that you have over here. Global temperatures were always below that, right? The global temperatures here, the estimates are the blue line, and then the black line shows you sort of the direction of those temperatures. But once you get to the beginning of the 20th century, global temperatures on average start growing very, very, very rapidly, right? Very rapidly. That's the pattern that the chart reveals, is a pattern that was hiding before in the data. The chart also shows you the level of uncertainty of these estimates, which is really, really high in the past. This gray area that you have over here is the level of uncertainty of these estimates, but it becomes narrower and narrower and narrower the closer we get to the present, because estimates become better and science becomes better, right? So in a small space, in a very, very small space, we have been able to summarize thousands and thousands and thousands of numbers. And by doing that, we are able to extract meaning from those numbers. This is the power of charts. This is the power of data visualization, right? And the potential that it has. Charts are also becoming popular and mainstream because they have a larger presence in news media, right? The usual suspects. I guess that most of you visit sometimes places or websites such as the New York Times or the Washington Post. But there are many others, many other news organizations that are using charts on a regular basis and more every day, right? Online-only publications such as Axios.com or 538 or ProPublica.org. One of my favorites, by the way, not many people know about this, but the relatively small conservative magazine, the Weekly Standard, also produces and publishes excellent data visualization on a regular basis. And then publications from all over the world, from Germany, from Spain, from Brazil, are adopting this language to communicate with their readers. And I believe that this is wonderful. I really love it. So that's the celebration part. Let's go to the concern part of the talk. Throughout my career, right, in the past 21 years that I have been either doing or producing or teaching data visualization, I have heard many misconceptions about charts, right? When I hear people talk about charts, I have heard them say certain things that I have come to believe that are not true. So I'm going to show you 4 myths related to charts, right? The first one is a picture is worth 1,000 words. Let me go back here so you can see that a picture is worth 1,000 words. That is not true, right? We need to append an extension to that sentence. A picture is worth 1,000 words if you know how to read the picture, right? I will get to that in a minute. Charts are intuitive. We all believe that. We all believe that. I always see a chart and say, oh, I understand it. It's so clear, right? No, very dangerous. Charts are misleadingly clear sometimes. We will get to that. Data and charts speak for themselves. This chart speaks for itself. I don't need to see anything else. It tells me everything I possibly want to know about this particular story. Wrong. We'll see that in a minute. Charts are means to simplify information and make information understandable. Wrong. Charts are not means to simplify information. They may be means to clarify information given certain design features. We will get to that as well. I'm going to show you an example of a chart that basically proves or corroborates my idea that all these are myths that are worth abandoning, right? Before I show you the chart, though, I need to tell you a story. I'm going to begin with that story. I'm a journalist. I love stories. So back on April 27, 2017, these 3 reporters from Reuters magazine, from Reuters, the news agency, met with President Donald Trump in the Oval Office to interview him after 100 days into his presidency, right? And I'm going to quote from the story that they wrote about this meeting. These reporters said that midway through a discussion about Chinese President Xi Jinping, the president, meaning President Trump, paused to hand out copies of the latest figures from the 2016 electoral map. Apparently, during the conversation, President Trump gave these 3 reporters copies of a certain map. One day after, one of the reporters went to CNN and he showed the map that President Trump had given him during the interview. President Trump loves maps. He loves visuals, which is something that makes me really, really happy because I love visuals as well. There's actually a photographic record of this interview. During the interview, again in 2017, there's a photograph of President Trump talking to the 3 reporters and with the copies of the map in there about to be handed over to these 3 reporters. President Trump loves this map so much that he also asked at the beginning of his presidency to print out large copies of the map, frame them, and hang them on the walls of the White House. And there is also a photographic record of that fact. None of this is Photoshop. Take a look at these, right? There you go. Just a reporter showed this photograph on the hallway, in the hallways of the White House with a White House aide about to hang that copy of the map on the walls of the White House. Not surprisingly, perhaps, President Trump has also tweeted about this map. A while ago, there was an interchange between President Trump and people who strongly oppose him and some people who strongly support him. So President Trump was trying to encourage people in Texas to participate in the primary elections in Texas, and he tweeted something like, I want to encourage all my Texas friends to participate in the primaries for governor and blah, blah, blah. And someone who opposes President Trump very strongly replied to President Trump, you have no friends. And then someone who supports President Trump replied to this other person saying, Really? Implying, do you believe that we don't have friends? Take a look at that map. Take a look at how many friends we have. We have many friends. Implying, take a look at the amount of red on the map. So many friends. And President Trump retweeted this person tweeting, such a beautiful map, thank you. Well, the map is very beautiful. The map is really beautiful. I love maps. That is also extremely misleading, very, very misleading. It has also appeared, by the way, on book covers, right? It appeared a while ago on a book called Citizens for Trump, written by author Jack Posobiec. There you go, Citizens for Trump, the inside story of the people's movement to take back America. And when I saw this book cover in social media, on Twitter, I replied to Posobiec. I try to be very nice to people when giving feedback about charts, which is something that I do very, very often. And I try to be as constructive as possible. So when I saw the book cover, I replied to Posobiec. I'm not going to quote myself verbatim, because I don't remember exactly what I wrote, but it was something like, I think that you either need to change the title of the book or change the illustration on the book cover, because the title doesn't describe what the map is showing, and the map is not showing what the title says. Because the title of the book is Citizens for Trump, but the map is not showing citizens. It's showing something entirely different. So I know that it may be a little bit difficult to change a map because you need to, use specialized software and stuff. So I actually propose changing the title for something that better captures what the map is actually showing. That's the title that I proposed. Counties for Trump. Because the map is not showing people. It is showing territory, the amount of territory, right? So remember the whole idea behind charts. The whole idea behind charts is the proportional representation of data through the variation of certain features of certain objects, right? If you are talking about people, and by the way, let me make an aside, it doesn't really matter that the book is titled Citizens for Trump. I would say exactly the same thing if the title were Citizens for Clinton. The map would be equally wrong, right? To represent people, because the title of your book is Citizens for a Candidate. And Citizens for a Candidate represents the amount of people who voted for this person, right? The popular vote in the 2016 presidential elections was 48%, 46%. Those are the numbers that need to be represented in order to title your book Citizens for Trump or for Clinton. The problem with that map is that the map is not representing 48%, 46%. The map is representing 80% versus 20%. If you take a look at the amount of red, the surface of the map that is covered in red versus the surface of the area of the map that is covered in blue, all right, that split is 80% versus 20%. That's the actual percentage of each one of those colors. And that's the reason why this map is so misleading, because it indirectly conveys the idea of a victory by a landslide, right? A victory by a landslide. That's the reason why some people love this map so much, right? What is the challenge, though? Well, first of all, it doesn't represent people, all right? And second, it's representing the amount of territory dominated by each one of the candidates. But not only that, it's also misleading because many areas on the map are actually empty. Nobody lives in those places, particularly in the Midwest, right? If you take a look at a map that represents people, like each person as a little dot, and then you try to locate each one of the voters close to where they voted, which is something that a friend of mine did a while ago. His name is Ken Field, a very talented cartographer. So Ken created a map in which he pinpointed every voter on a huge, huge map, right? And when he did that, you can see that all that area over there is basically empty, or completely empty, devoid of people, right? That's another reason why the original map is so misleading, if what you want to represent is number of people who voted for each one of the candidates, right? What would be a better presentation? Imagine that I am going to write a book titled Citizens for Clinton or Citizens for Trump. It doesn't really matter. Well, I could think of other visuals to represent people. I could begin, for example, with a simple bar chart. A simple bar chart that shows, in comparison, the amount of people who voted for Clinton, the amount of people who voted for Trump, and the amount of people who voted for other candidates, right? Now, what is the challenge? When I was thinking about this case, I told myself, is this really, this bar graph really capturing what happened during the election in terms of the amount of citizens who are voters? And the problem with that chart is that it doesn't really capture that either, because the largest group of voters in the United States didn't even vote. When you take a look at the amount of people who didn't vote and you include that in the chart, then perhaps we need to come up with a better title. Citizens for no one, perhaps. because it's 40%. 40% of people who could have voted in the election didn't even vote. In any case, that would be a much better graphic for a book cover, for a book title, Citizens for Whoever. Anyway, so this country is becoming so ideologically divided, which is something that really, really worries me, that I have observed that we are also becoming divided along ideological lines in terms of preferences when it comes to charts. I follow a lot of people in social media, both on the left and the right, up and down, from all over the political spectrum, and I have come to observe that conservatives, particularly those conservatives who support President Trump, tend to love that map very much. Every time that they need to talk, that they want to talk about the election, they usually use that map. Why? Because that map makes people feel good, because it's such a huge amount of red, such a little amount of blue, right? On the other hand, whenever a liberal person who I follow in social media replies to these conservatives, they usually say, hey, you idiot, why are you using that map? It's so misleading. You should use this other map instead. I have seen, liberal friends of mine tweeting this map, right, just to respond to the tweeting of that other map. This map over here represents data using area, right? The size of the bubbles is proportional to a number, right? The bubbles are color-coded also according to which candidate won on each county, right? And then the size of the bubble is proportional to the number of votes received by the winning candidate on each one of the counties. What I would tell to my liberal friends is that this map is also highly imperfect, because if you want to capture citizens for Clinton, citizens for Trump, there is a story that this map is hiding, which is that there are plenty of Trump voters in Democratic areas and plenty of Democratic voters in Trump or conservative areas. And those people are not represented in this map. So if you want to use a map like that, I would say perhaps you need to use two maps. One of them to show the amount of people who voted for President Trump, another one to represent the amount of people who voted for candidate Clinton, right? But one day, when thinking about this case, I asked myself, well, what if I run for president one day, right? And I win the election, I win a presidential election, I become president of the United States, and I want to print out a chart or a map to hang on the walls of my White House, or to give to reporters when they come visit me in my Oval Office. Just an aside, I cannot run for president because I'm from Spain, right? So I cannot run for president. I can run for Congress, though, which makes me really happy. That may happen at some point, who knows? But anyway, let's assume, just for the sake of argument, that I can run for president. I run for president, I become President Cairo of the United States. If I want to celebrate my victory, right, by printing out a map or a chart or something to celebrate my victory, I would not use any of those maps or any of those charts. Because the metric that really matters in the United States to win a presidential election is neither the popular vote nor the amount of territory that you dominate. What really, really matters is the number of electoral votes that you get, right? So the kind of chart that I would put on the walls of my White House and happily give reporters whenever they come visit me in the Oval Office will look something like that, right? It will be some sort of chart, bar chart, that shows number of electoral votes received by one candidate, number of electoral votes received by the other candidate, and then a couple of maps, one of them representing the results of the election at the state level, because that's what really matters, and then another map called a cartogram that distorts the areas of each state according to the number of electoral votes that they contribute to the election, right? Because this one gives you an idea of what weight each state has, or each state contributes to the results of the election in terms of number of electoral votes, right? So through this example and many others that I would like to share with you today, I have come to believe that charts lie even when they are correctly designed, because the original map that I showed you, the county level results map, there is nothing wrong with it. The problem with that is not the map itself, it's how we interpret it. So most often, more often than not, charts lie because we love to lie to ourselves. We love to have our ideas confirmed whenever we see data, and I will show you examples with that. The confirmation bias is a very strong drug, and it makes us feel great whenever we see it. By the way, I have another story related to this 2016 presidential election. And also on social media, after the election, I saw that this guy was planning to run for office. Kid Rock, I didn't know that much about him at the time, but Kid Rock announced that he was planning to run for the Senate, right, from Michigan, in Michigan, right? So I didn't know that much about this singer. I looked for him on YouTube, etc. I started following him on Twitter to see what he was tweeting about. All right, very funny guy. And I saw that he was promoting the merchandising that he sells in his online store. And one of the pieces of merchandising that he sells is a T-shirt that contains a map. And I love maps. I may buy that T-shirt at some point. It's a map, a T-shirt with a map of the 2016 presidential election at the state level, as you can see. Very beautiful T-shirt that you can buy for $25, right? I may need to start charging Kid Rock for free advertising. Anyway, so as you can see, I have erased the legend that the map contains. Obviously, the red is Republican and blue is Democratic. But according to Mr. Rock, the results of the 2016 presidential election correspond to the boundaries between two countries. The red country is called the United States of America. And according to Mr. Rock, the blue country is called Pakistan. So, as I said before, when talking about the book cover by Jack Posobiec, I like to offer my free advice to whoever wants to take it when it comes to chart design. And if I could talk to Mr. Rock, I would say that the state level results, the state level map of the 2016 elections is not a good representation, I would say, of the boundaries between the United States of America and Pakistan. Because I have lived in several places in the United States. Sorry. I have lived in several places of the United States, right? I've lived in, for example, in North Carolina, but I live, which is a red state, as you can see over there, but I lived in Chapel Hill, North Carolina. And now I live in Kendall, which is really, really close to Miami. And I can tell you that those two places, and I believe that that is also the case of Nashville, are not the United States of America. They are deep, deep, deep than Pakistan. And I am a great, so the state level, the county level map may be a better representation of the boundaries between those two countries, because I also believe that we need to be respectful of people's heritage and preferences. Anyway, so charts lie, as I said before, just to go back to the main idea, mainly because we love to lie to ourselves, right? So this talk originally, by the way, I basically entertained a different title for it rather than how charts lie, things like that. I entertained the title Graphicacy. Why Graphicacy? Because Graphicacy is basically what this talk is about, visual literacy or graphical literacy. It's a much nerdier title, right? Where did I get the title Graphicacy? I got it from a wonderful book by cartographer Marc Montmonier, a book titled Mapping It Out. In Mapping It Out, Marc Montmonier says that today, in order to consider yourself or ourselves educated citizens of a democratic republic, we need to have much more than literacy, right? Literacy is what is usually taught in educational systems, but we need much more than that. Besides literacy, which is the ability to write and read correctly, we also need articulacy, which is the ability to express yourself correctly through spoken words. But you also need numeracy, which is the ability to think about numbers. It's not necessarily statistics, it's more sort of a sixth sense in the back of your brain that tells you, this number that you're seeing over here, it looks a little bit dubious. Now, that sort of alarm is what numeracy is. You don't know why that number looks wrong, but it looks wrong to you. And then moreover, on top of that, he also says that we need more graphicacy, which is visual literacy or graphical literacy. So I have come to believe that we can do something about these, because I don't think that we are all graphic enough, right? We make mistakes all the time when we read charts. And we make mistakes at the three levels in relationship to the three main components of any chart. Any chart, like written language, has three elements, right? It uses symbols to represent the data. It uses a grammar to organize those symbols in a meaningful way. And it also has a semantics level or a semantics layer, which is the interpretation that you extract from that chart, the message that it conveys and that you can extract from the chart. And we make mistakes at all levels when reading all these charts. Let me begin with the easier ones, which is the symbolic level and the grammar level. The Pew Research Center, back in 2014, conducted a survey in which they show that they asked a sample of 1,000 Americans a lot of questions about science, right? Does the Earth rotate around the sun, or does the sun rotate around the Earth? Questions like that. one of the questions that they asked about science to this sample of Americans was, what do you see in that chart, right? That chart is a traditional scatter plot, which is a very traditional chart in the world of science. The chart is basically showing you that at the national level, there is a relationship between the amount of sugar consumption per capita, country by country. There's a positive relationship between that and the average number of decay teeth per country, right? In general, the higher the average sugar consumption in a country is, the higher the average number of decay teeth in that country, all right? So it's a positive relationship. That's what the chart means. Well, what the Pew Research Center discovered through this survey in 2014 was that 63% of people in the survey could read this chart at this grammatical level, all right? At this grammatical level, could sort of see that there is an x-axis, there is a y-axis, that the method of encoding is positioned. People could decode the chart that way, 63%. I usually say that this 63% is both good news, but it's also bad news. The good news is that 63% of people can read this chart. That's fantastic news. I can guarantee you, having worked in this business for more than 20 years, that if we could go back in time and conduct this same survey 20 years ago with average people, that percentage will be much lower. Why is that percentage so high? Because, for example, news media is using scatter plots over and over and over again, more commonly, right? And that educates people into how to read scatter plots correctly, right? On the other hand, the bad news is that there is 1/3 of people in this survey who couldn't extract the meaning from the chart, couldn't read the chart at the grammatical level, how to read this chart. They interpreted it as showing change over time and things like that, right? So they couldn't read it at the grammatical level. So there is something that we could do about this. And this is highly worrying, by the way, because the scatter plot is not a graphic form, a way of representing data that was invented yesterday. It's a kind of graphic that was invented back in the 19th century or things like that, right? Statisticians in the 19th century started using the scatter plot. For example, Sir Francis Galton, back in the middle of the 19th century, used some of the first scatter plots. But the level that worries me the most is the third level, the semantics, the interpretation. It is very easy to teach the symbolical system and the grammatical system of charts, right? I can teach you x-axis, y-axis, position, height, etc. I can teach that. That's the symbolical level, and that's in the grammatical level, how to read a chart. But the semantics level works in the interplay, in the interface between you and the chart, right? The chart tries to convey some meaning, but then you need to extract the right meaning from it. For example, without reading too much into the chart, which is something that I will show you and I will explain a little bit later. Most of the mistakes that I have seen throughout the years and that I have made myself whenever reading charts lie on this level of the reading, right? Because charts are never intuitive, right? That's one of the ideas that I want everyone to abandon. Charts need to be read instead of being seen. This is a mantra that I like to repeat over and over again. Many people believe that charts are like illustrations. You can just take a quick look at it and you understand it, and that's wrong. Right? As long as they use symbols and they use a grammar, they need to be read like a piece of text, So I have put together a list of 5 recommendations that I usually give people who want to become better readers of charts at the semantics level. The first recommendation is that once you have paid attention to a chart, when you see a chart in news media or in social media, the first question that you can ask yourself is the designer of this chart using appropriate data, showing the appropriate data? And is the data that is being shown in the chart measuring what the chart says that is being measured? That's another very important question to ask ourselves. So it can take us a long way to, for example, take a look at the primary source, where the data comes from originally, in order to make sure that the chart is measuring what the chart says that it is measuring. I'm going to show you an example of that. A couple of years ago, I saw a map in social media that I retweeted immediately because I absolutely loved it. It's a map that shows the concentration of heavy metal bands all over Europe, right? Chart that represents number of heavy metal bands per million people, country by country in Europe. I love this chart, this map, for several reasons. The first one of them is that I happen to enjoy hard rock, not very hardcore heavy metal, but some heavy metal bands also I like. So I love that. I love the map because of that. But also because it confirmed something that I sort of already knew. which is that in general, the colder a place gets and the darker a place gets, the more heavy metal you have. At least in Western Europe, the more to the north you move, the more heavy metal bands you have in comparison to the population of those countries. There are always exceptions to any pattern. For example, there is a huge amount of concentration of heavy metal in Greece, which is actually quite interesting. But, you know, the heavy metal capitals of the world are widely considered the northern countries, places such as Sweden and Norway, or in particularly Finland. Finland has a huge concentration of heavy metal bands. So I absolutely love this map. This map is so great. And I retweeted it. But then I thought twice. Wait, I said to myself, is this showing heavy metal bands? Right? And I'm going to explain to you why I thought about this. So when I saw the map, I decided to undo my tweet and take a look at the primary source of the data, where the data came from. The data came from, fortunately, by the way, the designer of this map disclosed the source. Good for him, so people can take a look at the source. The source of this data, this is good practice, by the way, disclosing the source of your data. The source of the data is a website called the Encyclopedia Metallum, which is a huge database of heavy metal bands, country by country, from all over the world. I scraped those data, by the way. I'm planning to use it in a project in the future because it's fantastic. It's a good data set. I'm getting ahead of myself. But anyway, I didn't know that before checking the source, obviously. So the way that I usually explain this to my students is that double check the data. Take a look at the primary source to make sure that this map is showing just heavy metal bands, right? And not other kinds of bands, right? How to do that? Well, I usually say that the first step would be to imagine the most paradigmatic heavy metal band, the most representative heavy metal band. Why do I recommend that? Because then you can compare all the or most of the other bands in the data set to that very representative band. Right? Imagine that that band is sort of the average of heavy metal, the one that embodies all the values and aesthetics of heavy metal. If most of the bands that are represented on that data set are more similar than dissimilar in comparison to that band, then the data set is measuring just heavy metal. But if many of the bands in the data set are more dissimilar than similar to this very representative heavy metal band, then perhaps they are not measuring just heavy metal. So I'm going to ask all of you to imagine the most representative heavy metal band in the history of rock music. Don't say it out loud, just imagine it. I bet that most of you have, imagined bands such as Metallica, for example, or if you are older, like I am, Slayer from the 80s or things like that, right? Well, I grew up in Europe back in the 80s. And for me, the band that better represents heavy metal, the band that embodies all the values, the sound, the aesthetics, the attitude of heavy metal is the British band Judas Priest. Judas Priest is, in my opinion, the most metal of the metal bands, more than any others. Let's go over these. Let's go over the features of this band, right? Let's think about the features that are related to heavy metal and that this band embodies. Let's begin with the external features, right? Long hair, very typical of heavy metal, right? The poses, right? Like very angry and very defiant and stuff. The tight clothes, right? Like the tight pants, black pants, and the spikes on the clothes, very heavy metal. The bikes, right? These dudes, whenever they play live, they enter the stage on a huge motorcycle, on a Harley Davidson, very heavy metal. So the external features are very heavy metal, right? Let's take a look at the performing features. Let's begin with the lyrics. I'm going to show you a representative lyrics from this band, one of their most famous songs titled Painkiller. So Painkiller, you can read the lyrics in there. They are very heavy metal. It's not a song about drugs, by the way. It's a song about a monster who is called Painkiller, right, and kills people and stuff, a demon or something like that, right? So they sing about demons and monsters, and very, very heavy metal. Now, what about the sound of the band? The sound of the band is also very heavy metal. So I'm going to show you, or so you can hear, how Painkiller sounds like, because it's very heavy metal. So this is Painkiller, the beginning of Painkiller. Oh, we need the sound on, sorry. Well, I can actually, you don't hear it, but basically you will hear the drums in there, and then they will start playing the guitar, and they headbang. That's also very typical of heavy metal. Particularly if it is synchronized, as I mentioned there you go, that's a synchronized heavy metal. And then the singers are screaming like crazy, right? So you can find this thing on YouTube. I actually found it on YouTube, and when I was putting the slides together, and I downloaded the video from YouTube, I went through the comments of the YouTube page, And somebody replied in the thread to the YouTube video saying, that's so fucking metal that all the refrigerator magnets came into the living room to see what's going on. So that's very heavy metal. Anyway. Anyway, this joke is much funnier if you could hear the song, but let's move ahead. But it's very metal. The fact is that it's very metal. All right, so let's go back to the source. So now we have this idea in mind, Judas Priest. So if all the bands in this data set are more similar than not to Judas Priest, then they are counting heavy metal. Now, why did I decide to do this? Because having read about the history of hard rock and heavy metal throughout the years, both online and in books, etc., I have seen other kinds of bands also being labeled as heavy metal. Actually, if you go to the Wikipedia page about heavy metal, you will see some bands mentioning that Wikipedia entry that I would not consider really heavy metal. For example, Poison from the 80s. Now, Poison, they are not similar to Judas Priest, right? You can notice that. The aesthetics, the poses, right? The lipstick and stuff. So that's not very heavy metal. They are hard rock, obviously, the rock metal, glam metal, whatever you want to call it. But they're not pure heavy metal. And I have also seen Bon Jovi labeled as heavy metal sometimes. That's crazy. Bon Jovi is not heavy metal. I mean, it's a fine band. There's nothing wrong with Bon Jovi. It's a good rock band, but it's certainly not heavy metal. Anyway, I went to the source, and the source doesn't mention any of these bands. Most of the bands that I saw mentioned in the source look very heavy metal to me, right? After doing that, I retweeted the map. That took me only 2 or 3 minutes to do, right? And why did I do it? Because I'm a great believer in that we all have a responsibility about the information that we share with other people. Today, we are all like traditional journalists in the sense that we are all people who spread information around a network of people. In the past, journalists used to be the gatekeepers, right? We had the access to the platforms to promote information, to put information out. Today, we all share those platforms, and we all have a responsibility to make sure, at least a little bit, that the information that we put in social media is likely right rather than being likely wrong. And we can only do that if we spend a couple of minutes making sure that Poison is not in the data set before retweeting the map. Anyway, so second point, is the data represented accurately, right? Remember the whole idea behind charts, the proportional representation of data in terms of varying sizes and things like that and colors. A while ago, there was a discussion in Congress among several representatives about whether the United States should keep funding Planned Parenthood or should defund Planned Parenthood. Before I get to the chart, by the way, let me tell you, I don't care what you think about Planned Parenthood. That's completely besides the point. You can be in favor, you can be against it. I couldn't care at all about that, right? But I do care about good charts because I believe that charts can enable civic conversations between rational people. Therefore, we need to use good charts to have those conversations. If we use bad charts, then we cannot have a good conversation about a worthy topic, such as should we fund Planned Parenthood or not. Anyway, so Representative Jason Chaffetz, from Utah, during the conversation, during these hearings, shared this chart. It's a chart that shows that the number of life-saving procedures conducted by Planned Parenthood between 2006 and 2013 dropped very dramatically, very, very dramatically. And then the number of abortions conducted by Planned Parenthood increased very dramatically during the same period of time. As you can see, one of them doubled, and the other one basically just dropped by half or something like that, right? Unless that you read the numbers, which are super, super, super tiny and very difficult to read. And you may notice that it's sort of true that the number of cancer screening procedures conducted by Planned Parenthood dropped from 2 million procedures to 1 million procedures between those 2 years, right? So they dropped by half. But the number of abortions didn't double. The number of abortions went up from 290,000 up to 327,000. The chart is showing you two things that look like they vary at the same rate, but they don't vary at the same rate. One of them drops very dramatically, but the other one doesn't increase that much. Vox.com called this chart out, and put the two variables on the same axis, on the same proportions. And you can see that this is a much better chart than that one, if you want to have a conversation about these issues, right? This one is not distorting the data. That one is distorting the data because it's using one scale for each one of those measures, right? Each one of those measures. And that is problematic. Moreover, there is another problem with the original chart, I would say, which is that it sort of cherry picks the data in order to make a point. Because Planned Parenthood does many other things other than cancer screenings and abortions. They also do STD testing, and they also do, for example, contraception services and things like that. And that is not contemplated on the original chart, and it should be if you want to have a conversation about what to do about Planned Parenthood, right? Designer Emily Schutz redesigned the original chart, including most of the primary main services that Planned Parenthood conducts every year, and she came up with this chart, which shows the variation of all these services. As you can see, it is true that cancer screening procedures went down quite dramatically, but then there are other services that have increased in terms of amount of service, like STD testing, for example, increased throughout these years, and contraception services sort of stayed the same, right? So as I said before introducing the chart, I don't care what you think about Planned Parenthood. That's completely besides the point. What I do believe, though, is that in order to have a civil conversation about any sort of issue, that chart is objectively much better than that other chart, because this chart is informative. Everything is to scale, everything is measured over the same scale, and it shows all the services provided by this organization. That one over there is propaganda. And propaganda doesn't improve civil conversations. It hinders conversations, which is actually quite dangerous. The third point is, does the graphic contain a sufficient amount of data, right? That's related to what I have just said, right? Is the chart showing a sufficient amount of data in order to inform you, or is it cherry picking the data in order to make a point? That's something that really, really worries me, okay? During the recent tax discussions, tax cut discussions in the United States, several representatives started throwing numbers around, right? Big numbers around. And big numbers, when presented alone, can be really, really dangerous, can be very, very misleading. For example, Speaker Paul Ryan shared the average American family is going to save $1,000 and something every year, which I believe is great, okay? I'm not going to disclose what I think about the tax cut, all right? That's completely, again, besides the point. But I do think that good charts are good for conversations, and this number alone doesn't really facilitate a conversation about the goodness or about whether the tax cut is good or not, the recent tax cut is good or not, because most American families are not average. My family is not average. I bet that your families are not average either, right? This is only showing you what an ideal family is going to save thanks to the tax cut. But in order to have a conversation about the tax cuts, we need to know more. We need to know how much different kinds of families are going to save thanks to the tax cut. So in order to have a conversation about that, I would say that you need to show, for example, you know, the distribution of income of families, right? This is not the income of families, it's the income of households, which is similar but not exactly the same. The distribution of income in the United States is quite skewed, right? This is called a histogram, right? A histogram. A histogram puts some sort of measure on the x-axis. That will be the income, right? You have very poor people over here, very rich people over here, middle-class people over here, and then the height of the bar is proportional to the number of families that you have on each income bracket, right? So you have the very poor people over here, the very rich people over here. There are many more poor families than rich families, right? So the number, right, that was shared, right, told you basically that people in this area were going to save around $1,000 a year, which is great. I think that that is a great idea, right? But at the same time, as long as I like to have discussions, I also want to know how much these people are going to save. I want to know how much these people are going to save. I want to know how much my family is going to save every year, right? I also want to know how much these people are going to save every single year, right? So it's much better to provide more information rather than less information if you want to have an informed discussion about this very important issue. Let me show you another very important issue that is also sometimes misinterpreted because we throw around charts that are highly simplistic, all right? Murders in the United States, all right? Now, this is a traditional chart that is used to inform the public about the murder rate in the United States, right? Murder rate per 100,000 people, right? Remember what I said before, by the way, when talking about the myths, the difference between simplification and clarification. This chart is a simplification, but it doesn't clarify. I'm going to explain you why. This chart shows you a story that most of us have heard, that is like during the 80s, the murder rate in the United States and violent crime in general increased quite a lot. Murders dropped during the 90s. stayed more or less the same during the 2000s, and then in the past 2 or 3 years, murders have started increasing again, which is a very, very worrying. It's something that we need to discuss. We need to talk about what to do about it, right? But in order to have that conversation, we need to ask ourselves, how dangerous is this, right? Well, it all depends on where you live. It all depends on where you live. Because if we could plot every single place in the United States on this y-axis, right? Remember, the y-axis over here is murder rate in the United States per 100,000 people, right? Imagine that we could plot every neighborhood, every place in the United States using a little dot along this scale. I can guarantee you that my own neighborhood in Miami, I mean, we have seen 1 murder in the past 6 years. So probably we will be down there, my neighborhood. And most places in the United States are very, very safe. By the way, this is just an aside. I lived in Brazil, so whenever I hear people in the United States talking about how dangerous this country is, so I sort of chuckle a little bit, because Brazil is really dangerous, depending on where you live also. The murder rate there is much higher. But in any case, most places in the United States are down here. They are very, very safe. What is the problem, and the reason why that original chart is so misleading? Because we are not discussing the role of outliers. There are certain places in the United States, and this is all based on discussion by statisticians who deal with crime statistics. There are some places in the United States that have become so dangerous in the past few years that if we try to plot them on the chart, they will go through the roof. They will reach the sky because the murder rate is so high. Right? Super, super dangerous. So these are neighborhoods in big cities, for example, like Miami or Chicago and Baltimore. They have such a high murder rate that they distort the national rate, right? So I will go back to what I said before. If we want to have a discussion about the murder rate, if we really want to address this problem, the original chart is too simplistic in order to have that conversation. We need to discuss not only that simplistic chart, but also the exceptions to the patterns that we are seeing that may be distorting that national rate. So we can target those places for action, right? Oh, sorry, what is going on here? The 4th point, right? The 4th point. Is uncertainty relevant? It usually is, but not always. Is uncertainty relevant? And if it is relevant, if uncertainty is relevant, is it well explained? The uncertainty in the chart, is it well explained? What sometimes it isn't, and it may be, or it should be well explained. Let me show you a chart that misleads everybody, and dangerously, in a dangerous way. Living in Miami, I see this kind of chart every single year, 3 or 4 times, right? By the way, this is the map from a tropical storm Alberto, and I have a story to tell you, and it's a true story. I was putting these slides together and also writing the chapter of the book dealing with these kinds of maps at the same time, on the same days that tropical storm Alberto was approaching the United States. That was a very happy coincidence. It was so happy that some friends of mine started emailing me quotes from the National Hurricane Center, from new releases from the National Hurricane Center, quoting what was going on with Tropical Storm Alberto. So one friend of mine, for example, emailed me this quote from the NHC: "Alberto is meandering over the northwestern Caribbean Sea." That was not true. I was in Miami writing. Or my favorite one: "Alberto is not very well organized this morning." Anyway. All right, so this kind of chart misleads everybody. Everybody, I can guarantee you that. Just a few people know how to read this chart correctly. Why is that dangerous? Well, because it is the chart that is usually used by news media to inform the public, to show where the hurricane could go, where the storm could go, right? Based on experimental evidence, showing that map to normal people and asking them, what do you see here? What do you see on this chart, right? We have observed that many people, when they see that cone, that's called the cone of uncertainty, right? Although some people in Miami call it the cone of death, because they basically believe, they call it that because they believe that it shows a possible area that may be affected by the storm, right? The problem with that map is that whenever people, not everybody, but many people see the cone, they see the scope of the storm itself, the scope of the hurricane itself. That's what people envision when they see the cone of uncertainty, and that is not what that map is showing. So how to read that kind of map correctly in case that you ever experience a hurricane? In order to explain how to read it, I'm going to explain how it is created. The way that that cone is created is, first of all, the National Hurricane Center collects tons of forecasts from different places. So tons of models of where the center of the storm could go, right? Imagine each one of those models as a line. It could go here, it could go here, it could go here, it could go there. They collect them all. And then using methodologies that I'm not aware of because I'm not a scientist, they choose, right, the one that they believe is most likely. And they pinpoint what they deem that is the most likely position of the storm in the following 5 days. Tomorrow is going to be here, tomorrow is going to be here, the day after is going to be here, the day after is going to be here, right? And they pinpoint those points that you see over there. Then, based on past successes and failures at predicting storms, they draw a circle of increasing sizes around those points, right, those circles. And then they, obviously, tomorrow, right, they can predict it with more accuracy than 5 days from now. That's the reason why the circle becomes bigger. And then they connect the circles, right, and that's what creates the shape of the cone of uncertainty. That's the reason why it's called the cone of uncertainty. So whenever we see a map like that, we should see something like that instead, right? You see the cone, you need to envision a set of possible lines, of possible tracks of the storm, of the center of the storm, just the center of the storm. Because another thing that we need to do whenever we see this kind of map is to overlay the size of the storm mentally, right? Because the storm is a huge thing, right? So it should look a little bit more like that, right? The path of the storm, but not only the size of the storm as well. This is how people who are a little bit knowledgeable about statistics read the map correctly, up to this point. From this point on, most people get it wrong, and I'm going to explain you why. The first time that I saw the cone of uncertainty, I asked myself, so I know that the cone is basically containing a range of possible paths of the storm. It could go here, more or less, of the center of the storm, right? I knew that, right? But I asked myself, does the cone contain all possible forecasts that have been made, all possible tracks, all possible paths of the storm? 100% of those forecasts, right? And that was not my assumption. When I saw the cone, I was assuming that scientists were telling me 95% of the time that we experience a storm like Tropical Storm Alberto, the path of the storm will be inside this cone of uncertainty. But there may be some rare cases in which the path of the storm could be outside the cone of uncertainty, right? That was my assumption because I remember Stats 101, I remember the concept of a confidence interval and all that crap. But let me tell you, sorry, I shouldn't have used that word. Anyway, so this is wrong. It's completely wrong. If you read the fine print from the National Hurricane Center, you will see that the cone of uncertainty doesn't contain 95% of possible tracks of the center of the storm. It only contains 2 out of 3. That means that 1 out of 3 times that we experience a storm, such as Tropical Storm Alberto, the path of the storm will be outside the boundaries of the cone of uncertainty. So whenever we see a cone of uncertainty, which looks like an actual cone, we need to envision something that resembles more a Spanish fan, something that is wider to encompass more possible tracks of the center of the storm. And moreover, perhaps we need to overlay the size of the storm, and the storm could go anywhere, right? Which is actually true. That's the reason why you need to be prepared for any storm, even if you are not inside the cone of uncertainty or close to the boundary of the cone of uncertainty. You should still get prepared for the storm anyway. And the last point, probably the most important one, and we go full circle back to the beginning of the talk, to this idea that charts lie mainly because we love to lie to ourselves. Ask yourself, am I reading too much into this chart, right? Moreover, am I reading too much into this chart because the chart confirms what I already want to believe? That is very, very dangerous. And I'm going to show you an example of what I mean. A while ago, I was witnessing a discussion in social media about the Affordable Care Act, right? Republicans oppose the Affordable Care Act because they say they hinder the ability of companies to hire people. It's so expensive to pay for health care. On the other hand, liberal pundits and commentators were saying the Affordable Care Act is great for the job market because, you know, people can get access to health care and blah, blah, blah. They can change jobs more easily. I don't have a formed opinion about that. I'm European. We have socialized medicine in Europe. I don't have an opinion about the Affordable Care Act. But I'm going to show you a chart that people on the left use, not everybody obviously, but some people on the left used to lie to themselves, right? So I saw some liberal commentators in social media using a chart that shows that the Affordable Care Act is great for the job market. I'm going to show you the chart. There you go. So this is a chart that shows the number of people, actually it's not the number of people, I need to correct that, is the number of jobs, right? The number of jobs created in the private job market, right? So here you can see the economic crisis, right? Back in 2007, we had that number of jobs in the private sector, and then we have the drop over there during the economic crisis, and then we have the economic recovery that fortunately keeps continuing and continuing and continuing, right? The number of jobs created keeps growing and growing and growing. And notice what happens very close to where the line changes direction, right? Obamacare was passed. Obamacare was approved. It was passed by Congress, right? So the people who are seeing in social media were basically saying, well, it is not true that the Affordable Care Act is bad for the job market. It's actually great for the job market. Take a look at that, right? And what I like to remind people is that a chart shows only what it shows and nothing else. What do I mean by that? The chart is only showing you that there is a sort of coincidence in time between the change of direction of the curve and the passing of Obamacare. That's the only thing that the chart is showing. The inference that there is a connection between Obamacare and the change of direction of the curve is something that is not on the chart. It's something that happens in your brain. That's the semantics of the chart, the interplay between you and the chart. You are confirming what you already want to believe, right? That's a problem. Moreover, we could think about alternative explanations for that change of direction. For example, I know that President Obama's stimulus package was passed in February 2009. So it could be that the money that got injected in the job market back there started kicking in a little bit later on, and that's the reason why companies started hiring more rapidly right after. That's a plausible explanation to the change of direction of the curve. Moreover, I could think about alternative scenarios, right? Counterfactuals, right? What would have happened if the Affordable Care Act died in Congress or were killed by the courts or something like that, right? Would the line showing you the number of jobs created in the private market look like that? More jobs being created without the Affordable Care Act? Or would it look like that? Fewer jobs created by the private sector? We don't know, right? So we tend to see too much, we tend to read too much into the charts that we see, particularly because we love to confirm what we already want to believe. Imagine, for example, I'm going to show you another example. Imagine that you are a heavy smoker, right? You smoke a lot of cigarettes, right? And people are telling you all the time, you need to stop smoking because it's really bad for your health. You're going to die too early, blah, blah, blah. I'm going to show you a chart that if you are a heavy smoker, will make you feel great. It's a chart that shows you that smoking cigarettes is great for your health. It's fantastic for your health. There you go. That's a chart that shows the comparison, the relationship that exists between annual cigarette consumption per capita and life expectancy. And as you can see, it's a positive relationship. At the national level of the data, basically you can show that the more cigarettes people consume, the more years people tend to live, right? You can see that relationship in there, right? Wrong. This is an example of several paradoxes and several biases and several misinterpretations that are very, very common. First of all, the traditional correlation is not causation, right? Like the case of Obamacare before, right? We cannot infer that the more cigarettes you have or the more cigarettes you smoke, you know, the more lives the more years people live are actually connected to each other. That's the first thing. Second of all, this is an example of something that is usually called the ecological fallacy. The ecological fallacy basically says that you cannot make an inference at the individual level based on data that is aggregated at a different level. Here we are seeing data at the national level, but you are making an inference at the individual level, right? The ecological fallacy says basically that sometimes when you start disaggregating the data, and we are going to do it now, that positive relationship that you are seeing may disappear or may even reverse, completely reverse, right? So does smoking cigarettes can help you live longer? Well, not really. If you disaggregate the data using, for example, income levels, which is something that I did in this chart, color coding the countries according to income levels, you may start noticing that there is something going on over here. I'm going to separate the countries by income levels so you can see them clearly. No relationship at all. Once we disaggregate the countries by income levels, you will see that the positive relationship is not clear anymore. It becomes much fuzzier, right? Here, income may be the confounding variable behind this relationship, right? Because obviously the richer a country is, the more likely that country is in investing more in healthcare. So even if people smoke more, they also have access to better healthcare, therefore they live longer. And they have better diets and so on and so forth, right? And if you go down to the individual level, right, if you see person by person, people by individual by individual, right? Smokers versus non-smokers, right? Cigarettes actually reduce the number of years that you live, right? This chart over here shows you that in general, people who never smoke or who stopped smoking many years ago tend to live many more years than people who are heavy cigarette smokers. So it's called an amalgamation paradox or Simpson's paradox also. Anyway, so what to pay attention at? I'm going to leave this slide again for you to take a look at because these, I believe, are the principles that we should pay attention to when we read charts. But I would like to make one last point before closing the talk for today. In the past few years, there has been an increasing number of books being published about critical thinking and quantitative thinking and statistical thinking and things like that, right? There has been some sort of a revolution in critical thinking, which I believe is great. There are many books out there that help people think better about numbers, right? Books such as Naked Statistics, How Not to Be Wrong, and so on and so forth. Wonderful books. And I believe that my own book, published next year, will contribute to this trend, focusing much more on charts, obviously, because unfortunately none of these books cover chart with enough depth, in my opinion. They are wonderful at other aspects, right? But while writing the book, I came to believe that explaining people how to be aware of the many ways in which numbers and charts may mislead us is not enough. We need to go a step beyond that. And the reason why I believe that is that statistics, numbers, science, charts, all these things that I have talked about today, they are tools. The human species, if there is something that distinguishes us from other animal species, it's not just our capacity for language, right? Language is a tool that we use to communicate, right? What distinguishes us from other species is our skill at creating conceptual tools that extend our perception, our cognition, our intelligence. We are an animal species who has as the differentiating factor our capacity to create those tools, to make those tools that make us smarter in some sense. Now, what is the problem with tools? That the exact same tool can be used both for good and for ill. So if there's something missing in all the ongoing discussion about critical thinking and quantitative thinking and becoming better at reading numbers, etc., is the ethical aspect. It's not just how you use the tool, it's what you use the tool for, right? So I envision statistics and numbers and charts, etc., the same way that I envision a hammer, right? Just to make an analogy, right? A hammer is a tool that you can use for different purposes, right? You can use it for good, right? You can use it to build houses, right? But the exact same tool can be used to destroy houses, the same way that a chart can be used both or either for build understanding or to destroy understanding, depending on how you design the chart if you are a designer, or depending on how you read the chart if you are a user of that chart, or how you promote the chart if you promote a chart that is actually quite dubious. You may be destroying the understanding that the people in your network may have about important issues. So I'm a strong believer in that everybody can embrace charts, and we should all embrace charts because they can be really useful. They can make us smarter, but only if we use them, first of all, wisely, critically, and then finally, ethically. That's the most important point, the most important part. Thank you so much. I'm not in a rush to leave, so if you have questions, I will be happy to answer them. Let me move over there.